And the paper is from Hyung-Il University, and will be presented by the first author, Nhan. Okay.
Good afternoon, Professor and everyone. My name is Nhan. I'm from University. So today I would like to present our paper, a facial expression recognition method for intelligent game application. I will present following the contents. The first is introduction, and the second is face region cropping, and next one is completed local binary pattern for exacting face image features. The next one is some experiments, and the last one is the conclusion. This paper presents a novel facial expression recognition approach based on completed local binary pattern model and support vector machine classification to propose a method for applying to intelligent game application and intelligent communication system. Especially in intelligent games, emotion recognition of players can be utilized in many ways. First, in interactive and multiplayer games, emotions of players can be transferred to the players' avatars. For example, this is the emotion of the player, and her emotion will be transferred to the avatar. In educational games, recognizing players' emotions can help the system how to behave in a good manner. For example, if the player is very happy after doing something well, the game system can cheer the player up. Or if the player is too sleepy, so the game system can do something to wake the player up. So this is facial expression recognition system. It includes three main parts. First is face acquisition. This part is how to capture the face image, and sometimes it combines some normalized methods in order to obtain the good facial image. And the next part is facial feature extraction, and after that we can recognize the facial expression. So I move to the face region cropping. Human face images from the camera or database commonly contain much redundant information. For example, background or body regions, non-face region, So to determine the face area and eliminate some redundant regions of the face image, the real-time face detection algorithm developed by Choi is employed, as in the figure. However, this face region is not, it still contains redundant information for facial expression recognition. So we improve by we can choose the face regions like this. So we can say the biggest way is the face image we cropped by the real-time face detector, and we try to cut the square S, the smaller one. So first we determine the W2. W2 is the width wide of our face. So we test on some databases and found that normally the width wide of a human face occupy from the 75 to 82% of the W1. So in our experiments, we choose W2 based on our experiments. And the next one is how to decide the PXY in this. So we observe and we can see that our forehead is normally contains about 1/4 of our face head, and our forehead actually is not. It doesn't contain too much information about facial expression. So because of this, we trim 2/3 of this part and just remain 1/3 of this part. So we can crop this square. So this is, we can say that compared to the real-time face detector, we can crop in both method like this. So the objective of this cropping method is to eliminate face image region that contain little or nothing of facial expression recognition, facial expression information, such as our brow, ears, hair, or background of images, as much as possible. It means that the cropped face image region contains as maximum facial expression information on minimum area as possible. So I will introduce about the complete local binary pattern for extracting face image feature. Actually, the complete local binary pattern is developed from local binary pattern. So I will introduce about local binary pattern first. Local binary pattern (LBP) was first introduced as a complementary measure for local image contrast. You can see in this, it is this is central visual. So we can choose this value for a threshold. So this is the neighbor. We compare this value to this value. If it's greater than or equal the center value, so it will be set as 1. Otherwise, it will be set 0. It's smaller, so we set 0. So we will have the binary string. This is the basic LBP operator. So actually, local binary pattern is applied for facial expression recognition, but after that, people try to combine the style component and the magnitude component. So this is a complete local binary pattern with SP is the style, and MP is the magnitude. So we can see in this is a mark, and this is the local difference with the central result. And from this, we can divide in two parts. This is the psi component. If this value is minus, so we can set it as 0, and otherwise we set it as 1. So we can see that this psi component is LBP operator. So, and how about this? People try to combine with the difference of magnitude. So this is we have this much, and in order to combine LBP and psi component and magnitude component, it has to have the same structure. So we can choose like this version. In this, we have the threshold C, and C in this to be set at the mean value of NP from the whole image. So to this time, psi component and magnitude component have the same structure, so we can concatenate two histogram. So we have the CLBP histogram. For facial expression recognition, uniform LBP is usually applied in order to reduce the size of feature vector. So in our method, we use a uniform CLBP. And we also test on some different thresholds in this version. And we found out using the value C as the value of NP from the match, just on the mask, will often be best accurate in facial expression recognition. In order to extract LBP feature, often face image have to be scaled and divided into regions. So there are some ways how to divide the image, but we propose as following. First, we resize the face image into 64 multi 64 pixels, and after that we divide it into the 8 multi 8 pixels for extracting feature. After that, we concatenate. We calculate this histogram, and after that we concatenate and create the CLBP histogram, the image. And this feature vector can be used to classify. Our experiment, we test on two databases. First is Japanese female facial expression. It contains more than 200 images. And the second one is a facial expression and emotion database. It's more than 2,000 images. And we use a threefold cross-validation we use the supervector machines of OpenCV and use the radio basic function code. And this is the experimental process based on 3 parts as we say that reprocessing, feature extraction, and recognition. This is the result of the GEFFE database. This is a confusion matrix of GFE database at 80% of W2 per W1. So we can see that in this segment, Sadness is lowest accuracy, and happiness and neutral has the best. And we have the accuracy is more than 96%. So about fifth database, this database has is more challenges because it has some people have the breast or wear glasses, or some people they express their feeling weakly, and beside that, some people have expressed their feeling confused with the others. That's why in confusion matrix we can see that, for example, sadness, this can be recognized as a neutral, surprise, fear, disgust, and anger. And in this database, sadness has the lowest accuracy. We have the average accuracy more than, it's nearly 93%. I move to conclusion. We presented a novel approach for facial expression recognition based on the improvement of completed local boundary pattern model. Our experimental results show that choosing a suitable threshold in computation zero BP can obtain the better recognition rate in facial expression recognition application. Our method is simple, fast, and high accuracy. So it's suitable for real-time systems such as data-driven animation, intelligence, games application, and intelligent human-machine interface system. So thank you for listening.
Okay.
I have a question for you. I'm wondering if you consider the rotation of some data, then definitely the image band is better. And your approach is based on machine geometry, right?
Yes.
Then finally, the feature boundary will be restored. And I think that if the person rotate their head, then the value will change.
Yes, actually it is.
In your experiment, you consider that the facial scale
Yes,
is
I
very
have.
important issue in facial expression.
Yes. Actually, in our experiment, we based on two databases. Is GFFE and FIT database. And this database is normally used for facial expression recognition. And two databases actually people just change their head a little, not too much. For example, if they are too fear, maybe they can change like this, not too much. So the accuracy is quite high. So I know that if the face head can change a lot, maybe it's not have the very high accuracy.
Okay. Any other question? So it seems that you haven't integrated this into any game.
Actually, not yet.
Oh.
Actually, not yet.
Do you have any plan with that?
Actually, our idea is how to transfer the player emotion into the avatar, the character in the game. So in the interactive game like this, maybe I think the feeling of the player is better because it's have the interaction.
Okay, thank you very much.